Hello everyone, welcome to the Hosting Applications Network's webinar, about how we migrated Oddschecker to GCP. A few housekeeping things first. Everyone will automatically be on mute. There is a questions function in the chat bar on the right hand side. Feel free to ask questions throughout. I'm going to try to keep an eye on them and answer them in the specific sections. If not, or if one doesn't maybe fit into that section, we'll have a question section at the end where we'll go through those. If you're having any trouble hearing or keeping up, maybe have bad connection, don't worry, this will be recorded and the recording will be available. Hopefully everyone can hear me. The microphone bit is going up and down, so it sounds like it can. So as I said, my name is Steve Olds. I lead the cloud specialist team here at Clarinet and do quite a bit of our consultancy, and I was actually directly involved with the initial pre-sales with Oddschecker. I'm here in person with my friend from Oddschecker,
Matt Robinson. I'm head of technology from Oddschecker.
Great stuff. And we've also got my colleague on the line.
Hi, I'm Tim Berry. I lead the engineering team for Google at Clarinet.
Wonderful. Okay, so just to go through at a very high level what we're doing today, just click to the next slide. There we go. So we'll do a little bit around Clarinet, not too much on that, just a bit of an explanation of who we are for those maybe haven't met us before. Then similar about Oddschecker and the situation. We'll then kind of go on to what we wanted to achieve and how that then decided the technology, how the process then went on, and then some kind of wrapping up statements after that. So to get through the bit probably people might already know, Clarinet are a UK started but now global MSP, founded in 1996. We're still a private business, owned by a guy called Charles Nasser, who's very involved in the business. We've got revenues now of over 350 million, and we operate largely in Europe. We've got business in Brazil, and actually through recent acquisitions, we also have some presence in other territories such as Australia, the US. About 2,000 employees now, which is significantly higher than when I joined, and we are recognized as a leader for cloud-enabled managed hosting. How do we generally work? Well, we focus on business very heavily, so we absolutely do need to understand people's infrastructure. More important than that, really, we need to understand people's applications, but we need to understand how those applications affect business processes, and then how it understands business. And that's very much how we approached this project with Oddschecker. We really talked in depth initially about what the problem was, what this piece of infrastructure was delivering for Matt's customers. So now to probably the more interesting bit for most of you, I'll hand over to Matt to talk through Oddschecker and why we started this journey.
Thanks, Steve. So for those that aren't aware, Oddschecker was first established in 1999. We are the UK's largest odds comparison website. So it's our job to take prices from all the different bookmakers around the world, aggregate them all together, and showcase them to the customers in a digestible format, which allows them to then get the best value when they're trying to place bets on their favourite sport or special markets. So in terms of sort of user base, we have about just slightly over 2 million unique users per month, and we're actually directly or indirectly involved in more than 1 in 10 online bets. So
really? I didn't realise there's that many. Wow, okay.
So in terms of the problem, so obviously we used to be based in a physical data center, and for those that may or may not be aware, obviously scalability can be a problem in a physical data center, especially when you don't own it. So we had a lot of problems scaling. So sports traffic tends to be quite spiky, so we need to scale up or scale down very quickly. So having lots of redundant hardware is not very good for the business. So actually the lead time for getting hardware installed in a data center was sometimes about 3 to 5 months.
Months?
Yeah,
not
to get
weeks.
it installed, no. So that obviously means we couldn't scale at all. So we basically got to a point where we were hitting our max capacity, and we basically needed to get out. So it was holding us back from opening up new revenue streams and products. So we basically needed to move out of our data center, and the cloud was sort of the most logical option. Additionally, some of the other problems were kind of managing the overhead of a data center, so listening up for hardware failures and things which we don't really need to manage anymore with public cloud. And kind of as I touched on already, kind of being able to sort of experiment with different technologies and being able to change our tech stack without having to worry about affecting any production loads. So that was some of the main reasons why we needed to move to the cloud.
Yeah. So in summary, your business couldn't grow more because you were held back by the technology.
Yeah.
Yeah. It's not an uncommon thing to hear, but I do remember when we were talking about it. In your case, it was pretty extreme. Like no further feeds able to come in, this kind of stuff. Yeah. It was a real challenge. So with that in mind, what were we trying to achieve, and what were some of the key pieces around that you needed to tackle in this project?
So I suppose, as you said, we were holding our sort of business growth back, so we couldn't onboard more bookmakers and things like that. So we basically set ourselves some quite aggressive timescales to do the migration. So we actually set sort of 12-month timescales. We did an initial POC, which proved that we could run stuff in the cloud, and that basically set the groundwork for our sort of 12-month migration timeline. As I sort of touched on already, we wanted to achieve a scalable platform, so being able to scale with the demands of the business, and also kind of improve our way of deploying software. So being a data center for sort of 10+ years, we built up a lot of technical debt and a lot of sort of bespoke ways of deploying software, so there wasn't a lot of consistency, and we kind of had a centralized sysadmin team that had to do a lot of deployments, which was sort of holding back the speed at which we could deliver software to our customers. And like I said, there's technical debt both in the infrastructure and software side, so improving our infrastructure, so see through 10 years of technical handcrafting and things like that, there was a lot of stuff that may have been unknown in our data center, so removing a lot of that so we can rebuild our infrastructure with one click, but also improve our applications and make them run a lot more in a scalable manner. And obviously that means that we get to create a nice environment and entice environment that people want to work in, so giving the guys a platform that they can sort of thrive in and build a lot better software and go and enjoy what they do.
Absolutely. So a few things jumped out to me in that. A 20-year-old business, which most people still consider relatively young, born in the internet, as it were, still has significant tech debt.
Yeah,
it's not uncommon at all. I'm not that surprised by it, but a lot of people probably think, well, we have tech debts, we've been going for like 100 years or something. It still happens, right? People leave, you change direction, something suddenly becomes this. I was with someone recently, they called it Black Ops. I just didn't know how this particular app worked anymore. Did you just sit there then with considering the spiky workloads, with spare capacity for most of the time, and then when you got hit, it still wasn't enough?
So we actually, because we didn't sort of have to pay for the hardware running and the sort of the cost of the electricity in the data center, we basically were running at max capacity the whole time. So we didn't have to worry about scaling up because it was just running with max capacity. So we could take the sort of Grand National or Cheltenham traffic quite easily.
But when Oddschecker became separated out from the business it was part of previously, suddenly that stuff's going to start having a cost.
Yeah,
and that would have been
when it was part of an acquisition, there was a timeline on when we had to move out. Yeah, we got out well ahead of that.
When you said you did a POC, I think a lot of people listening will absolutely be familiar with that term and the fact that they do. It's a good first step for most people. What did you do as your POC? What kind of thing did you pull out to try?
So we had we were working, I think, with the Daily Mail at the time to do some sort of integrated widget for some of their news pages to sort of entice the people to stay on their article rather than clicking out to an operator's website. So obviously in our data center, we couldn't probably handle the traffic of the Daily Mail.
Right,
so
it
was kind of a new project to kind of try out what we could do in the cloud and kind of see. And it was a greenfield project, so we kind of didn't have to worry about migrating anything.
But similar enough to the rest of the stuff you do, right? So it proves the case.
Yeah. So we did it in a similar sort of tech stack, sort of run it from KH from the outset, and we had that with some aggressive timescale as well. So we think we did the POC in about 2 or 3 months.
Yeah.
And we survived our first Cheltenham on the Daily Mail, which is a good achievement.
So for those that aren't as down with the kids like me, K8s is Kubernetes. I had to have someone explain that to me relatively recently. Right. So how we met? From what I recall, so we've not really gone through this, but I added this in. We met at a Clarinet event about security and compliance for gaming at Google.
Yeah,
it was, wasn't it? And we got chatting about it. He's kind of talked. I think he talked around the POC, and then we decided we should go and do a whiteboarding session. The whiteboarding session with yourself, your colleague Jason, who's a top guy. We had Sam on our side, and I seem to remember, I kind of consider myself normally pretty techy and pretty understanding, and a lot of it was just flying over my head. I learned a lot in that couple of hours, but very quickly there was a synergy, wasn't there, in terms of, like, we were excited by the same things you were.
Yeah. There was a lot of problems and sort of bespoke hardware solutions that we didn't really understand how we could solve in the cloud. So sort of Clarinet were helping a lot with that. We sort of come up with a few solutions during that whiteboarding session that we actually ended up going with. So it was great.
Yeah, and after that, really, it was pretty quick to get started from what I remember. I mean, it's a little while ago now, but we just kind of said, this is what we're going to try doing in these phases. Off we go.
I think it was probably within a month of having that whiteboard session we were starting.
Yeah, and that's when you got introduced to Tim.
Yeah,
and hopefully, Tim, I didn't design you a lemon to have to build. It was a pretty exciting project for you to pick up, wasn't it?
It was, yes.
Wonderful. So the next piece really for me is why containers. Now, I think generically, Tim, you're obviously a massive advocate and almost evangelist on containers and Kubernetes, but for you, ignoring Oddschecker for a moment, why do you think people should be looking more at containers and Kubernetes?
I think they're the most logical abstraction for the best way to deploy applications in the cloud. We've been deploying applications in the cloud for years now, and before people were embracing containers, we were still trying to deploy things in a way where they could be auto-scaling, self-healing, and basically as reliable as possible. That's the whole methodology behind site reliability engineering, which is what we practice. But before containers, when you're still dealing with virtual machines, there's an awful lot of scaffolding you have to put around those configuration management systems, things like Puppet and Ansible, and you're maintaining a lot of different state, and a lot of code just to make sure that things can kind of self-heal and self-drive. Containers abstract a lot of that away. They make things a lot easier because you're able to package an entire application, including all its dependencies, in a single thing, the container. That makes it very powerful, and it also makes it very easy and efficient for developers to build applications and to iterate on them because of the way containers work. Then you combine that with, well, how do you orchestrate those at sort of production scale? And Kubernetes provides, again, all of these abstractions that allow you to do very nice things, like make sure things are up and running at a certain scale, make sure that they can react to peaks in demand for traffic. You can control deployments. It introduces all sorts of object abstractions for things like rolling updates and canary testing. And it's kind of the most production-ready orchestrator for containers out there at the moment. Obviously, it's come out of over a decade of Google running containers at scale internally with their own systems, which eventually turned into what was then open sourced as Kubernetes. So there's a lot of clever thinking that's gone into the design of Kubernetes, and we've just had nothing but great experience with it.
And you're actually running kind of courses now and kind of labs days on Kubernetes, kind of 101, and specifically on GKE, aren't you?
That's right, yes. So we do a one-day workshop that starts off just sort of introducing people to the concept of containers, best practices for how you get an application into a container, making it as lightweight as possible, avoiding anything that you don't need in that container, and then moving on to how you deploy that with an orchestrator like Kubernetes. And at the end of the workshop day, we actually do some CI/CD, doing some continuous deployment, using a sort of GitOps workflow, which again is just another way to enable your developers to deploy changes to applications, new features, much quicker than they used to be able to. You're kind of taking out all of the legwork, the operations process of having a change to an application thrown over a fence and scheduling a change window, and then having an operator deploy an application with a rollback plan if it doesn't work. You abstract all of that away into essentially a Git workflow, so that a developer can make a change to an application in a Git branch, and your CI/CD system can respond to those changes in Git and push out those changes, but in a very controlled way with minimal risk to traffic, using one of those different methods I just talked about. So we covered all of that in that one-day workshop.
Yeah, I was in one. Was it last week? In Bristol, and it was really good actually. I think the labs really made it, but I think there's some more of those coming up in other places around the country, aren't there?
Yes, we've got one in London on, I think it's the 22nd of March.
Great stuff. So that gives us a great understanding of containers Kubernetes from a very technical kind of standard background. Why did you guys start? Because you decided before we even thought about, before we even met. So what made you guys decide you wanted to do it? Because you weren't using containers previously at all.
No. So we used to run a lot of stuff on VMware or on sort of bespoke processes running on servers, and we kind of didn't have a consistent way of deploying software, and everything was so intertied, and we were quite tied down to what technologies we could use. So we basically did a POC in our data center with a very small KX cluster, realized we could get our stuff running there, and it was a lot easier to manage, and kind of self-healing and that kind of stuff was a real benefit to our application. Even our legacy code was able to run in there quite happily and sort of restart itself, which was a big relief from the operational overhead that our sort of ops team are having to manage and restart applications a lot of the time.
And so some people kind of consider changes like this, refactoring, moving to public cloud, as being culturally quite difficult, but the guys were really excited to start working with this, right?
Yeah. So they were kind of, obviously any developer doesn't like working on legacy tech stuff, and if you show them something new or like a way that they can improve what they're working on, they'll always jump at it.
Absolutely. And I think from what I remember, there's quite a bit of work for the developers to do as part of this. It wasn't just simply move it, but they still enjoyed it. They still saw the purpose behind it. They saw the ease of operation, the reduced blast radius for problems and stuff like that, and they really just cracked on, didn't they?
Yeah. I suppose we as well as doing the cloud migration, we decided to migrate to Kubernetes all at once. So the guys had a lot of work to do migrating everything to running Kubernetes, but they loved every minute of it.
So next, I think I'll start this time with you, Matt. Why did you choose GCP and therefore GKE? Because you can obviously run containers in many, many ways. You can run Kubernetes on virtual machines like you're doing in your data center. What made you choose to go Google and then specifically put yourself into GKE?
So we chose, as I sort of said, we were doing this POC, we did a sort of POC KX cluster on-prem, and then we rapidly realized that managing and hosting Kubernetes yourself is a massive burden. It's a pain. Yeah. So our platform team were taking up a lot of their time having to manage that. So obviously we started looking around then for sort of hosted providers, and at the time Google was the only one that offered a managed service for Kubernetes, and obviously Google, being the creators of Kubernetes, made sort of logical sense for them to have the best managed hosted KX platform, which we rapidly found out was the case when we did our POC.
From a third-party point of view, it also felt very much like the Google team interacted with you guys very well. They really got involved. They were really keen to work with you, and I thought they conducted themselves brilliantly as well throughout the process. Do you agree?
Yeah, they did. I think we got access to a lot of sort of, as well as the solutions that we went through with Clarinet. We obviously did a similar exercise with the Google guys, sort of accessing some of their sort of engineers and solution architects to kind of help us come over some hurdles and sort of tweaks on some of the platform problems. So it was good.
Yeah, because they get it, right? They get it. Tim, is there anything specific? I mean, you've kind of built your career, and you could have gone anywhere, but you built your career around Google, GCP and GKE more so now as things move that way. Was there anything that particularly, drove you to move to a Google life?
I think it's interesting because Kubernetes is such a sort of ubiquitous thing now for building platforms and for building places to run software. But running it on Google is great because not only is GK arguably the most mature managed Kubernetes service offering out there, but it is. But also there's zero vendor lock-in. It's still Kubernetes. There's no extra parts that Google add to it that keep you on GKE. So you can absolutely use GKE. It's the easiest, quickest path to start deploying production workloads in Kubernetes. But you can move those to any other Kubernetes cluster in another cloud provider on-prem. You can even use, as part of Google's new cloud services platform, you can spin up GKE nodes in other places, in other providers, or in your own premises using GKE on-prem. So that's kind of what drew me to GKE originally, is the fact that it's as I said, it's the best way to do it, but also it's not going to tie you down there. You're not locked into anything, which is how it should be. It's a nice open way of doing things.
And although it's come out since we did this project, Istio is pretty exciting too, right? And the managed Istio service around that. Yeah,
so Google are pushing very hard, their engineers on integrating Istio with GKE. I believe at the moment in beta, it's basically a tick box. If you want Istio as a service mesh on your GKE cluster, you tick this box and you get it. And that obviously adds a lot more control over your sort of traffic policies and security policies, and you get instant end-to-end encryption between any communication between pods running in your cluster, and that's all just with ticking a box, which is pretty impressive. And they're also working on Knative, which is going off topic a little bit for this webinar, but that's a really interesting technology that's going to be bundled with GKE. But again, it's completely open source. It's also being developed by IBM and Red Hat and a few other people. And Knative is essentially a serverless platform that gives you all of the functionality you'd expect from something like Lambda or Cloud Functions, but as part of your GKE cluster.
Yeah, it's pretty exciting. And like I said, they're really pushing hard, and it's a really interesting area to keep an eye on. And I think we're both pretty excited about what will come out at Google Next in a few months now in the arena. Great stuff. So I'm not going to really talk on this next slide because it's not really for me to say, but why did you choose Clarinet?
So, as sort of mentioned originally, we sort of had some quite aggressive timelines, and our platform team at the time was a team of 2. So being able to achieve a rewrite in that time wasn't going to be achievable. So we needed to work with a partner that could work with our existing team. And the way that Clarinet sort of would work with us was sort of giving us basically resources that were integrated and augmented with our team, meant that we could sort of just continue working as usual, just with additional kind of resource in the team. And obviously their expertise while our team had some GCP experience, obviously guys from Clarinet had done a lot of migrations before to GCP. So taking their knowledge and obviously applying that to our migration sort of helped a lot when we had any sort of snagging or issues. They were able to sort of use their knowledge to work through that. And also they were able to help with some of our sort of development. So actually getting our applications to run in Kubernetes on GCP, some of the developers needed some additional support or some additional. It's good to have an additional escalation point, and Clarinet are there to help provide that for our team.
That's interesting. So Tim, with you being boots on the ground, what did that look like? How was that app piece done, and how did we work alongside the guys to make sure they hit those timelines?
Yes, I don't know if you want to go to the next slide. There's a couple of things on there that cover this and how we work in general with this sort of engagement. So, like Matt said, we kind of consider ourselves as an extension of a customer's team. We're working from the same Kanban boards. We're collaborating on the same tasks. So there's sort of 100% knowledge sharing between us and the customer as we work on this stuff. So even though we were pretty much the architects and designers of the solution at the beginning, then we're working together as a team to get the thing built. And we do that with various forms of communication. We have a Slack channel that we share with the customer. I mean, we all live in Slack as it is anyway. And then there's regular stand-ups where we discuss what are the priorities, what's next in the to-do column of that board, any blockers and that sort of thing. So we're collaborating 100% on getting the work done. And yeah, it was a combination of we knew what we had to build from an infrastructure point of view. That was quite straightforward. And then the bulk of the work was how do we define these deployments in Kubernetes for these applications so that they work exactly the way they need to work. And then, as Matt said, a little bit of, okay, we also have some other applications that aren't containerized. What can we do with those? And it's quite nice. My team, we're all SREs, but also we all have programming backgrounds as well. So we're able to look at, if you have a Java monolith, we can help you get that into a container. And so we did that for a couple of applications for Oddschecker as well.
Great stuff. And I think we were quite lucky in terms of we both already used Slack, both had stand-ups, so we managed to just set up a joint channel, which is something that I added to Slack last year, which is really helpful. And then we also kind of did stakeholder catch-ups as well as the stand-ups on a technical level. Myself and Matt and Jason would catch up, just to kind of go through things and kind of, there was a point where we actually kind of changed some focus and bits like that just to make sure it worked well within Oddschecker. And yourself and Tron, who were involved in the project, were able to take that on board really easily and make it work. I think one of the biggest challenges that I remember was just the pure amount of work on both sides, but the Oddschecker side while you were still doing BAU.
Yeah, I think that was kind of probably one of the biggest challenges, was managing kind of the BAU workload for the team, so keeping the lights on the current platform while we're trying to focus on building this brand new platform. And obviously getting that balance right was a challenge. I think obviously having the additional resource from Clarinet there sort of helped us be able to sort of maintain that balance so we could continue working on the project as well as keeping the lights on from the side.
Great stuff. So we've done all that, we've gone through it, we delivered it on time.
Yep.
What's it meant?
So obviously now we are working on a platform that is 100% running on Kubernetes and obviously 100% out of GCP. In terms of from a developer's perspective, we've made all our deployments consistent. So now the developers have full access to the CI pipelines. They can it's sort of moving towards a kind of no-ops approach now, where the guys can actually be responsible for their deployments and kind of manage it themselves. So we had a few instances where guys were able to release services all the way to production with minimal input from our platform team. Obviously, now we're there, we've been able to sort of scale our product offerings. So we've created a few new products and platforms that we wouldn't be able to do if we weren't there. This enabled us to kind of scale to the demand, both up and down, of kind of spiky traffic loads that we have to deal with. And kind of obviously being now in Google, we've been there for about 9 months now. It's kind of, we're now starting to sort of focus on using some of their managed services to kind of improve our platform. And there's no point in trying to create a Redis cluster and run it yourself if Google offer one as a managed service. Yeah. So actually being able to kind of integrate those components into our platform so we can focus on our creating business logic and value for customers instead of having to focus on running trivial infrastructure. So we're doing that as well as sort of focusing on building some sort of cloud native products. So actually being able to move to a more kind of streaming based approach for our data ingestion is that's only been enabled by us being on GCP and using a lot more of their sort of cloud native products that they offer.
I think something you said there is very interesting, that something trivial like running infrastructure, behind things like Redis, which, not that long ago were big, meaningful tasks, but now they don't have to be, right? And it's a real change. And I guess you're able to onboard new feeds and stuff now, right?
Yeah, so we're able to sort of grow, and now we're kind of in the process of, like say, we're able to grow and onboard new partners and work in the way that we should have been able to do.
Which was one of the real challenges at the time. And spiky workloads, no bother anymore?
No, so our Kubernetes clusters scale up and down with our workloads as traffic sort of demands come through the site.
And because of the way you've broken down the application, this is my understanding of it anyway, where it's broken down to such a point that if certain parts get particularly busy, because people go through a journey through your app, right, it's really efficiently scaling the right parts at the right time. So you're not just scaling everything without it.
Yeah, so we've segregated our infrastructure to be more component based, so we can scale up and down, like say, specific components of our platform to cope with the demand. Like say if we had a massive ingestion of data, we can scale that up, and the customer sort of facing parts of the application just casually just as they were.
And this fact that you are now building new things, trying new stuff, and really focusing on innovation is one of the reasons you're actually now hiring again. You're looking for more people to help you drive that growth in the business, right?
Yeah. So we're always looking for great engineers, and I think it's obviously starting to sort of having a platform like this for people to work on. It's actually becoming a lot more of an attraction for getting engineers through the door. It's been great.
It's far more enticing than tin, right?
Yeah, definitely.
Great stuff. So that's everything I really wanted to go through today, and that we'd kind of discussed. Here's a chance for people to ask some questions. I've had a few come through. First one, what are the technologies we used? So there was some compute, right? There's some bits in that. So,
yeah.
So what else was used between yourself and Tim?
So our tech stack, we're primarily sort of a Java house. So a lot of our backend infrastructure is backend application logic is written in Java. As well as Java, we kind of have a big Elasticsearch cluster. We were using things like Cloud SQL,
right.
And then we then also kind of built our infrastructure all through Terraform. So now all our infrastructure is as code. Yeah. So it's click to redeploy, which is a great place to be in for a DR perspective.
Cool. And so Tim, with so we just talked about Cloud SQL. I know initially we had a file share requirement, so I think Gluster was used. Were there any difficulties kind of plumbing this stuff into Google, into GKE?
I think, in fairness, yeah, the only difficult piece of the puzzle was the shared file system. The best option for us at the time was to stand up a GlusterFS cluster in compute. There isn't a managed service for shared file storage in Google at the moment that is highly available across multiple zones. I believe that will be happening soon. There is certainly a very good one in Cloud File Store available now within a single zone, but the business requirement here was that the availability of the applications wouldn't be affected by the loss of an availability zone, which is an extremely rare event anyway. But we always build, the Kubernetes clusters are regional. Pods and deployments and workloads can move around between zones. So the only way to ensure that was to build out the shared file storage in Gluster. We've been working on some alternatives to that more recently. Again, just abstracting it through Kubernetes and using regional persistent disks in the background. But that was the sort of production-ready way to do it at the time.
And so, although there's a management overhead and the complexity to setting up GlusterFS in general, it was easy enough to. Matt cringe. It was easy enough to plumb into to work together, right? Everything, GKE, GCE, Cloud SQL, they're really easy to get to work together, right? That's how it's all designed.
Yeah, I mean, we do everything as code, infrastructure, deployments, applications, everything is code. So we're still automating the creation, the management of that GlusterFS cluster. Kubernetes itself has an abstraction for external services. So the way that applications inside the cluster communicate with Gluster, they just see it as another service. Then they have no awareness that it exists in compute and not actually in the cluster itself. So it's very easy to join all of these things up together.
Great. So I think we've partially already answered this next question, but the question is, what went wrong and what challenges were there? Were there other challenges other than, was Gluster the main one, or were there other ones as well, other than BAU as well? Who wants to go? Tim? Can you remember any?
I think I don't recall any technical challenges other than obviously the volume of the work, the number of applications. There were always, you're never going to get a monolithic application that hasn't been containerized yet to run first time in a container. There's always some tweaks that need to be made, even if it's simple things like changing the way it logs, so that the logs can be consumed by the metric service that you're using inside the cluster. But I think the main challenge was anything that we had to stand up outside of the cluster in compute. But again, it wasn't really a challenge. It's just more work. You abstract away so much of that operational pain when you use Kubernetes, especially with the Matt touched on the way that the pipelines that we put in are now being used to enable the actual product teams and developers to own their deployments all the way through to production. I mean, I don't think you can oversell Kubernetes enough as an enabler for innovation, because again, I've been doing this long enough to remember when a deployment to production meant several months, a change approval board, and an entire other team actually doing it, and then it would never work the first time. And if you can get your new features and changes out to production quicker than your competitors, then you're the one that's going to win in the market.
Great stuff. The other question, which is a bit tricky to answer, as I'm kind of meant to be an agnostic person, but comparing the offerings for similar things in AWS and in Azure, what I would say is, they're all trying to achieve the same thing. So they are trying to remove the requirement to handle the masters and some of the management layer and try to make that a lot easier. I've done more with the AWS version, the Azure version, so I can't really speak particularly much on the Azure version. I've had people that have tried it and actually largely have ended up going with the Google one. But with the Amazon one, I think it's certainly proved it's doing that more, but Google have been doing it so much longer. They came up with the technology. I think it's they're always going to have a bit of a foothold here and be a bit ahead of the game. The integrations with this, the things that are coming out, the fact that now they're pushing that you can run GKE with the same kind of config capability anywhere is a real strength and power. And I think this is going to be an area that Google will continue to dominate for a while. Any other questions for anyone? I haven't seen any more come through. Oh, here we go. Hang on, I've pulled this one across now. Why did you decide to go with Kubernetes and not with App Engine? That's a good question.
So we did look at App Engine, but the way our applications were written and obviously our reliance on some of the data stores we used, it would have been a lot more work to actually migrate stuff to run on App Engine rather than just a straight wrapping it in a container and getting it to run on Kubernetes. So
extra refactoring work to make it fit.
Yeah. So we chose Kubernetes, and also with Kubernetes, you still would maintain the flexibility. That as long as it runs in a container, you can kind of deploy it. So it's enabled us to kind of start introducing lots of kind of new technologies away from kind of Java, so we can pick the right tech for the right job rather than having to use a Java container.
Tim, is there anything you'd say on the comparison between Kubernetes and App Engine? I know you're a big advocate of both.
Yeah, I mean, I love App Engine. I think it's really good for specific workloads. If you have a web application as opposed to 50 microservices, then App Engine is a really good bet. It's rock solid. It's fast. It's still serverless in that you only pay for the compute as it runs. But there's you've kind of got all those options in Google, from compute, Kubernetes, App Engine, all the way to Cloud Functions, and you can imagine on the one end you've got a lot of configurability, and on the other end you've got a lot of agility, and you kind of need to pick where on that scale you need to put your workload based on the workload itself. So in this case, obviously Kubernetes Engine was the right choice. If Oddschecker's website was a single application, then perhaps App Engine would have been the right choice, but it isn't.
Fair enough. Thanks very much for that. I'll just give another kind of 10-15 seconds, see if anyone wants to add any further questions. While I leave those 15 seconds of people hopefully typing furiously, I just want to thank everyone for joining. Like I said, this will be recorded and be available, so you can also pass this out to colleagues and friends who I'm sure will be desperately interested in Kubernetes. No further questions have come through, so yeah, thank you for your time. Thanks, Matt, for joining.
Thanks, Steve.
And Tim, thank you for dialing in.
My pleasure.
Wonderful, and everyone have a great day.